Hello students, welcome to the Yupp Master. Today we are going to learn the interesting topic in 8th class physics foundation course. So we would like to know about that dimensional analysis and dimensional formula and its applications in entrance examinations. So if you are going for IIT entrance examination, surely they will ask that one question in mains level and in advanced level. So let us have a look into dimension analysis and its applications. Yeah, if you are taking that a derived quantity can be expressed in terms of fundamental quantities, it is very clear. Now if you are taking that dimensional analysis and its application, it is going to extend that what is the use of dimensional equation, how you can use to check the correctness of a one derived quantity and one equation in order to frame the relation among different physical quantities, how it is useful. You know very well about dimensional formula. Yeah, while you are talking about that dimensional analysis, it is used to check the correctness of a equation in physics, and it can use to frame the relation among the different physical quantities. How it is possible? Let us see that. Now let's have look. Yeah, you can know that. So Q be the quantity, it's a one physical quantity. It can be expressed as m power plus or minus a, L power plus or minus b, T power plus or minus c. It is very clear. So one physical quantity, it is derived quantity which can be expressed in terms of fundamental quantities, that is m, L, T, and also 7 base quantities also there. Now you can take that dimension analysis can be used to apply. Yeah, let us assume it is useful to check the correctness, of equation or correctness of formula. Right. Let us assume that V is equal to U plus AT. This is a one derived relation. So you can easily find out that dimension analysis is going to be correct or not. To check the correctness, that is V, it is going to be L by T, and it is going to be L by T plus what about L by T square into T. Yes. So finally what you have been obtained, that is equal to L by T, that is L by T plus L by T, if you are going to make the cancellation. So what happened, if you are going to have the one relation, you can easily check that relation. You can easily check the relation on right hand side and left hand side. It's very clear. Now let's go for use, another use. You can take that. If you want to compare, this is the LHS is equal to RHS. Yes. It is very clear, we have been verified that it is correct. So, left hand side and right hand side, it is going to be correct. Now, is it possible to convert one system of units into another system? With the help of this dimension analysis, we can convert easily. That is nothing but from SI system to CGS system, CGS system to SI system, it is possible. Let us see how it is possible. Yeah, if you are taking that, you can take that M1, L1, T1 power A, B and C is related to, if you have going for this one, N2 into M power if you are going to take that conversion, that is SI system to CGS or CGS to SI system, we can take that. Suppose in your examinations they are going to ask that question, you have to convert that 1 Newton into 1 dyne. How it is possible? With the help of dimension analysis, you can easily find out that. Let's see that one possibility, that is convert, what is N1? You can take that N1 is the value, N1 physical system, N1 is the value of the derived quantity in the one system, N2 is the value of the derived quantity in another system of units. It is very clear. These are all the fundamental quantities, you know very well, MLT, all these are. Now, let us go for convert 1 Newton into, you can take that into dynes. 1 Newton into dynes, you can easily find out that 1 dyne, yes. Now, let us say if you are going to take that Newton, it is the unit for the force in SI system, right? You can take that, this is force, it is the expression for force is, you can take that mass into acceleration. You can take that. It's very clear. Now, dyne is also, it is the unit of the force in CGS system. This is in SI system. Now we have to convert. So simply, if you are going to take that you have taken, yes, you can take 1 Newton, you can express that its mass is going to be kg and length meter and second square. This is, we can take that x, we do not know that value, it is going to be x dynes. 1 Newton is equal to going to be how many dynes? Just we have to take that. Dynes, it can be expressed in terms of CGS units, that is, what about that mass in grams? In centimeter second square. Yes, this is the first equation and this is the second equation. We know that very well. So, if you want to find out this x value, this is the x, you have to find out this x value. So, what can I write? Therefore, x is equal to Yeah, x is equal to kg by grams meter by centimeter s square by s square. Just we have to take that. This is the case. Yes. So, easily you can write down here. Your aim is to convert one system of units into another system. It is very clear. Like that, if you are going to take, yeah, you have to convert in terms of grams. Yeah, it is very clear. That is 10 power 3 grams by 1 gram, 10 power 2 centimeter by 1 centimeter, whole power 1, and this is also whole power 1, and we can take that cancellation, this is 1. Now, if you are going to take that, that is, you can take all the cancellations, and 10 to the power of 5 dynes. Just you have to take 1 Newton is equal to 10 to the power of 5 dynes. How it is going to be possible? With the help of m1 by m2 power 1, L1 by L2 power A power B, T1 by T2 power C. This is the case we are going to take that. Please have a look. Let's see this one, this type of conversion. If you want to convert dynes into newtons, it is possible. You are going to express that dynes in terms of the newtons also, it is very clear. So, it is possible to express that one system of units into another system. So, this is the representation which is related to the one derived quantity in one system. This is, it was expressed as n1 into m1 L1 T1. Yeah, you have to take that powers. The powers has been raised to a particular value. So, this is the way we can convert that dimensional, we can convert that dimension analysis and its applications. You have to express that value of a one physical quantity in any system, right. Now, let us go for another one. Yeah, principle of homogeneity. It is very clear. The homogeneity means you are going to apply that one kind of operation, same, it is same on right hand side and left hand side. Let us take that. Homogeneity is a one principle. You can apply the same kind of operation if they are having the similar quantities. Let us see. So, you can take that, yeah, there, if you are going to take that one physical relation dimensionally correct, if the dimensions of fundamental quantities are same in each and every term. Suppose if you are going to take that summation A is equal to B plus C, we are going to, similar kind of physical quantities are going to be added. Suppose this is A is a one kind of physical quantity, B is also same kind and C is also same kind, then only you can add that. You can go for that principle of homogeneity. So, same kind of physical quantities are able to take that summation. Yeah, you can confirm this is A and this is A. Suppose this is V, yeah, this is V1, this is V2, let us assume. So, you can take that, this is a, you can take that, it is a velocity. So, this is also velocity, initial velocity, let us assume initial velocity plus final velocity. Yes, this is the case, we can take that. Is it possible to add that same kind of dimensionally? It is possible, you can take that summation if the physical quantities are same kind, then we can take that as a summation. We can express in terms of the summation. It's very clear. Now, can we add that acceleration to that velocity? Is it possible? So if it is same kind, then only we can add. It is very clear. Now, let us go for another one. Example, if you are going to take the general case, you have to represent that 2 apples plus 3 apples, 5 apples, just for our general representation, we can take that. 1 banana, 2 bananas, 3 bananas. It is going, if they are going to be same kind, you can express in terms of sum. Either many number of quantities are there, we can express in terms of the sum. 2 plus 1, 2 plus 3, 5 apples, same kind they are going to. Is it possible to 2 bananas plus 3 apples, it is possible to express as the summation is a one result? Yeah, obviously we cannot add them as a single entity. Similarly, 5 meters plus 3 meters, that is equal to 8 meters. Just we can take that 5 meters plus 3 meters, we can take 8 meters, right. So, this is L, this is also L, it can be expressed as a L. We are going to take that in terms of some fundamental quantities, that is length. It is possible, it was expressed in terms of, we are going to consider that the symbol, we are not considering that magnitude, we are considering that way of the physical quantity. So, the physical quantity can be expressed as a fundamental quantity, it can be expressed as a another same kind of fundamental quantity, it can be expressed as similar. So, summation can be expressed in terms of one quantity, right. Let us go for another one. Time also, yeah, you can take that time, yes, you can take that 3 seconds, 4 seconds, it can be taken as a sum, yeah, yes. Is it possible through 3 meters plus 4 seconds can be added, can be taken as a summation? It is not possible because they are not the same kind. Meter, that is a one kind, and second, it represents that length, it represents the time. So, length, time are the two different physical quantities. We cannot express as a summation, or it is not possible to represent as the single entity. It does not take as a single entity like that. In the previous cases, what we have taken, yeah, that is in terms of 8 meters, that is in terms of 7 seconds. So, we have taken that 4 seconds plus 3 seconds, that is going to be 7 seconds. Previously also, you can take that meter. Finally, what can we conclude that matter? One entity or 2 entities or more than 2 entities, they are going to be expressed as a single entity, that is dimensionally, that is going to be dimensionally. If all are going to be same kind, if all are going to belong the same kind of physical quantity, then only it is possible, right. That is called principle of homogeneity. It is going to be principle of homogeneity, applied same kind of operation to all, if you are going to take that, right. Yes, obviously we can add them as a single entity. Yes, we can add, subtract, yeah, it is going to be subtraction also. Yeah, we can equate any physical quantities of same kind or same nature, it is very clear. So, if you are going to take that one physical quantity which can be expressed as a summation, if you are going to take the summation, it can be expressed as a single entity. That is what you can add up that 10 velocities, you can add up that 10 seconds and 5 seconds. And so, whatever the time intervals, a body has that motion in different time intervals, that can be added to the single entity, right. It is very clear. Now, let us go for another one also. What we have discussed, yeah, This is the fact that only these quantities, yes, these quantities are going to be added up. A, B, C are related as, according to this, A, B, C are related as, if they are going to be as that same kind, same, yeah, that is of same, they are having same dimensional formula. So it is very clear. We are going to take that next one. Yes. It is what we have discussed about that these two physical quantities must have the same nature. That is very, very important. When you are going to take that addition of the two physical quantities, these two physical quantities can be expressed as a single entity when it is possible if these two are having the same nature. That is very clear. Yes, that's what we can take that. Yeah. Now we can check the correctness of the equation. Yeah, we can check the correctness of any equation. Principle of homogeneity. Using the principle of homogeneity of the dimensions is possible. It's clear. Yeah, we have to take that, check the correctness. Check the correctness of equation for S is equal to ut plus half at square. Yes, you can take that one equation. What is S? Distance travelled by the body. You have to take that. You can write here. What about that? Yes, you have to write down S is the distance travelled, and u is the initial velocity. You can take that initial velocity, and a is the acceleration, and t is the time. We can take that. This is a simple description about that the physical quantities involved in that equation. The set of physical quantities are expressed as a one equation. You have to check it whether they are going to having the correct relation or not. When you can confirm on the left hand side and right hand side, if you are having that same dimensions, that is going to be correct. Let us see. Yeah, you can take that, dimensions. Yes, it can be, you are going to take that, yes, it is going to be represented in the L, and u, it is going to be represented as L by T. Yes, you can represent it as a L by T, that is you can take that velocity, that is equal to displacement by time. You can take that velocity is equal to displacement by time. Obviously, you will take that T is in terms of T. Yeah, it has been taken as a fundamental quantity T, that is, and acceleration A, it can be expressed as L by T square. Acceleration is the rate of change of velocity. You will take that simply, for it is of kind L by T by T. Just you are going to take that. This is the rate of change of velocity. Yeah, you can take that. Can you substitute all these parameters? Yeah. Now you can take that, yes, L is equal to L by T into T. This is the first one. Plus you can take that 1 by 2, and you can take that L by T square into T square. Yes, all of you have been substituted that dimensional formulas which are going to be identified, and these are cancelled. Yeah, you can take that. You can take, so you can take that L is equal to, yeah, you can take that L plus L. You can ignore about this magnitude. So finally, left hand side LHS is equal to RHS. Yeah, you have to take that. Now you have confirmed it is of kind same. Yeah, they are going to be expressed as in terms of summation. Dimensional formula left hand side and right hand side going to be correct. It is very clear. To check the correctness of any equation, so dimensionally it is going to be correct, then we will consider in actual practice. It's very clear. Now let's go for another one. Yeah. Already we have discussed that conversion of one system of units, applications of dimensional formulas, conversion of one system of units into another system. So is it possible to convert that SI to CGS system? If you are going to take that 1 Newton is equal to 10 power 5 dynes, how it has been obtained we have seen. It is very clear. Now this is in, these are all the expression for the force, if you are going to take that. Now you can confirm the system of units are related to the dimensional formulas. Easily we can convert them, one system to another system. If you have been measured that density in a one system, easily can you express that density in another system? Is it possible? Very clearly it is, but you have to know that formula. Yeah. We have discussed to check the correctness of equation. Yeah, to derive the relationship among the physical quantities. How it is possible? It is very clear. You can take that Q1, Q2, Q3. These are the physical quantities. How they are going to be related? These are physical quantities. You can confirm that Q is equal to some constant K into A, B, C. You can take that. So Q, it is going to have the relation Q1, Q2, Q3. If you want to express the relation between these two set of the quantities, we can take that K, it is a one constant. It's a constant. We can easily frame the relation among the physical quantities which are of the same kind. These are of the same kind. Let us take that another one. Yes, easily we can convert that by using this equation also. Yeah, consider the physical quantity having the dimensional formula. It's very clear. Yes, we can take that in the first system, its value is N1. Second system, we can take that N2, its value is going to be N2. Yes, finally you can obtain this equation. Yes, what we have confirmed that we can express that the force in terms of newtons or dynes. So you can convert that Newton into dyne, that is with the help of this equation. Very clear. So easily we can find out that. Let's go for another one. What about N1 and N2? Please take that. N1, it is the value, N1 is the numerical value in the first system. N2 is the numerical value which represents in second system. Suppose you can take that, yeah, N1 and it's a value, just N2 it's a value in one system. in a second system. It's very clear. Now, if you are going to take that 1 Newton is equal to 10 to the power of 5 dyne, you can take that. So, it is of SI system, it is of CGS system, you can take that. It's very clear. Now, let us go for another one, conversion of units and correctness of equation. We have taken that examples V is equal to U plus AT, very clear. V is equal to U plus AT, we have verified that. How you can verify this? Let us see. If you are taking that, whether it is the correct relation or not, how you will find out, how will you can confirm? Please take that. This is that we can substitute, yeah, V is equal to final velocity and U is equal to initial velocity. Now, you can take that whether if you are going to take a one body which is in motion and its initial and final velocities are going to be measured, and you can confirm that acceleration, there exists a acceleration which is denoted by that A in the meanwhile time interval of t seconds, just you can take that. Yeah, A is the acceleration, you can take that acceleration is a 1 and t is the time. They are all dimensionally correct or not, you have to check that. You can confirm that it is going to be for velocity, it is represented by displacement by time, it is displacement by time, you can take that time. How you can write down V, it is equal to L by T, it's very clear. Now, you can write down L by T and this is also L by T plus this is L by T square and this is about T. So, finally, you can substitute and you can do the calculations, that is L by T, that is L by T plus L by T. So, it is dimensionally correct on the left hand side and right hand side. We are going to represent the summation in a single entity. You are going to take that summation. This is the summation. Yes, this is a single entity. Very easily you can confirm that. The summation, it is going to be expressed as the single entity. You have taken that one term or two or three or whatever it may be on the right hand side. They are going to be expressed in terms of single entity. It is very clear. Now, let us go for another one. Yeah. That is what we have confirmed. So, let us see, we are going to deal that interesting topic, that is, have you seen the picture which is going to narrate that one daily life situation? In your daily life, you are having that one opportunity to travel with the railway transport. Now, a person, he is going to sit on the bench, but he was at rest position, simply he was at rest position. Now, you can confirm that rest and motion both are relative with each other. You can take that with respect to the position, it does not change, no doubt at all, and you can take this is the one. This is the case what we are going to see. Please have a look. The train, it moves in its direction of motion. we will take that, yeah, with respect to that person who is in the train, there exists some relative motion. He feel like that the person who seated on the bench, he is going to move in the backward direction. So actually he was in the rest position, those who have seated on the bench. So rest and motion are relative with each other. In the view of one frame, it is in rest, but you have been observed from another frame, it is going to be in motion. Very clear. Now our aim is you are going to narrate that rest and motion both are going to be relative with each other if their position is going to be changed. Can you take the one example? A student has been seated on the bench in the classroom, he was in the rest position. He was observed by another person outside the classroom. He was on that permanent place. So the same student can be observed from another planet. What happened? He might be in the rest position, you can think he was in the motion. With rest, that's what the rest and motion are going to be relative. You can differentiate from one frame to another frame. But the person has been observed by the another one from the moon. What you can? If it is possible to observe from that moon, he has been observed by one person like X, you can take that. So then you can confirm he was in the motion, because earth is going to be moving in its orbit. So it is going to have that the observation, rest and motion. Yeah. Now whether an object is in the motion, you can measure the speed also. It is very useful. Just you can see that. Yes, speed, you are going to take that speed. So you are going to confirm about that speed. It is going to having that, yeah, distance covered per unit time. Yeah, distance covered per unit time, just we can take that. So we are going to take that, yes, you can take that speed, that is equal to distance by time. If you are going to take that speed is equal to distance by time, easily you will convert that in terms of kilometer per hour or in terms of meter per second. Just you can take that. Let's have a look. That is conversion of 1 meter second into kilometer per hour. You are going to take that. In the problems they are going to convert, they are going to mention about that in meters. Sometimes you need to express in terms of kilometer per hour. Just have a look. Just you know very well about that. Yeah. If you are going to take that distance and time, these are very, very important. Yes, you can take that. Yeah, 1000 meters is equal to 1 kilometer. Yes, you can take that. Yes, 3600 seconds is 1 hour. 1 hour. Yeah, you have to take that. If you are going to express that, yes, let's have a look. You are going to take that, that is meter per second, kilometer per hour. You have that conversion very easily. You can convert from meters to kilometers, just they are going to have the conversion. Yes, you need to get the multiplication of 18 by 5 and 5 by 18. Just you can take that. Yeah. If you are going to take that, just what we have taken, just you can write down the units in minutes. Again you can convert that minutes in terms of that seconds, easily you can identify that. 1 hour it's going to be 60 minutes, 1 minute 60 seconds, easily you can convert that. Finally you have that 18 by 5 kilometer per hour, 1 meter per second is equal to 18 by 5 kilometer per hour. So meter per second to kilometer per hour it is going to be converted. So lower value is going to be converted into higher one. So you have to multiply with 18 by 5, that is very important. And at the same time, if you are going to take that kilometer per hour to meter per second, you have to multiply with 5 by 18, that is very clear. Please take that. Yeah, its dimensional formula is L by T, m power 0, because there is no involvement of that mass. If you are going to take that L and T, distance covered, it can be taken as L and T. So simply it is going to be L by T, that is LT minus 1. So you can write down m power 0, you can write down m power 0 L T power minus 1. This is the dimensional formula, please see that, right. That is what we are going to confirm. You are taking that one system of unit and you can take the relation in another system of unit and you can express the value, you can express the magnitude, and finally you can convert. Like that what we have taken kilometer, meter, hours, seconds, easily you can convert. Now let us go for another one. Yeah, easily you will convert that 54 kilometer per hour is going to be converted into meter per second. Yeah, you are going to take that kilometer per second. This is actually, this is the case we have to, yeah, we can take that 54 into 5 by 18, that is 15 meter per second. It's very clear. We are going to get that multiplication with 5 by 18, right. It's very clear. Let's go for another one. Easily you will convert. This is also in the matter. We can convert. So we can express that force also. Have you seen this? Yeah, if you are going to express the role of force towards the center, it is going to be centripetal force, which is going to maintain that continuous motion. So that force which keeps that equilibrium condition, they are going to be balanced forces. Please note that. In the coming classes, we are going to know about all these kind of topics which are related to our present topic, that is force, speed and acceleration. All these are very clear. So have the nice occasion to learn with the Yupp master. Please convey to all the people as being a well-wisher.